Hello, good morning. Stuart Spector here at our workshop, Woodstock, New York. And just starting here in our parts for woodwork. There's wings for neck-through bodies. This is quilted maple from the Pacific Northwest and local sycamore from right in our area here, glued together to form the wings for our neck-through body bases. There's also this is water-cured redwood from the Pacific Northwest. Also, this was from a stump of a redwood tree that was probably cut down about 100 years ago and it slid under a river, and they need to get permits and chains to drag these stumps out of the river, but the minerals in the water darken it and wash all the sugar and stuff out of it, and really is beautiful wood. Nice to use it completely and not have to go to waste. Here's a bolt-on coda body with a buckeye burl top on it, which is also mainly from Northern California. These are from the stumps of the trees, and the gray color in it is asphalting, which is, it's sort of like the blue cheese of wood. And the spalting on this occurs in these grayish clouds. Here's also a guitar body in the same thing. When you put the finish on it, the contrast increases tremendously. Here's a really fantastic piece of it. Here's also, I'll show you some pieces that go into it. Here is some of our carbon fiber, which is used to reinforce the necks. This will get, each of the necks gets 4 pieces of this in addition to the truss rod. And it's called a pultrusion. It weighs 20% of the weight of a piece of steel, but it's just as stiff as steel. And absolutely fantastic stuff. Really adds strength and stability to the necks. And of course, if you're building a neck-through body instrument, you don't want anybody to ever have any problems with it, because your options are sort of limited. Heavy-duty truss rods also that go inside the neck. Part of our small stash of some of our fingerboard material. Here's some lovely ebony, and this is a Bolivian rosewood that we use called Palfero Caviuna. There's a piece of it that's not as dusty. And this wood is virtually as hard as ebony, but tremendously stable. We've made many thousands of instruments with it, and I think I've seen one hairline crack in almost 40 years of thousands of instruments. It's wonderful wood to work with. Let's see, what else? Okay, hi, this is our Vidal vertical machining center. This machine weighs 11,000 pounds. It's a wonderful piece of iron, very, very stable, and has a large amount of torque and horsepower to it. It's a metal machining center that you can use to make aircraft engines. It's accurate to 1/2,000 of an inch, even as an old machine that this is. Brand new, they're accurate to 2/10,000ths of an inch. I'll show you some of the uses of the accuracies a little bit later. But among the cool things is its automatic tool changer. This carousel holds 21 different cutters and drills. And during the course of an operation, it will go ahead and grab one of them, do the operations it needs to do, and then grab the next one in sequence. So with certain bodies that we're making, we may use 5 different cutters and drills, and it's just a fantastic tool, one that I've bought for a long time and has made just all sorts of new products possible, because anything that I can draw in 3D, we can machine with this equipment, so it's really opened up a lot of wonderful possibilities. One of the other things I want to say about this technology is that all of the tooling, the patterns, are in the computer. So your main challenge in working with it is holding the piece of wood in the same place every time. And then you can utilize the information that's digitally stored and activated. This is going to be a new fixture for our bolt-on base nets. We developed a new way of profiling them, but this is just the first stages of the platform for it. A neck through the body 4-string base plank at its earlier stage. The inlays and thread slots are already in here. I'll show you how we do that in a little while. Ebony peg head that's been cut out for our peg head logo on the CNC machine. The neck is 3 plies of hard maple. This one's going to actually get a Doug Wimbish taper with an 1.5-inch wide string nut on it. This wood for the necks comes from a supplier in western New York State, out near Buffalo, that's been in this business for many, many years. And interestingly, in western New York State, you get some of the best, cleanest hard maple in the world because of the geology. As the glaciers receded, they left topsoil that's 50 or 60 feet deep there. So when the maple trees grow in the harsh winters there, so they're very strong in relation to that. The roots don't go down and hit bedrock and pick up gray stains, because generally people, guitar players, don't want nice, nasty stains in the neck, and so this is a good place to get that wood. It's 5-string bolt-on neck. This has black mother-of-pearl inlays in it and a bird's eye maple fretboard. You can see the fret slots are already cut, which we're doing with a high-speed spindle, which I'll show you in a little bit. The beauty of it is that when we taper the neck, we stop short of the fret slots, so the fingerboard basically has maple binding of its own material right there. So the ends of the frets are never in danger of exposing themselves through the finish, which can really ruin the finish. Earlier stage of completion. These are ready for fret finishing and sanding and scraping. Here's the neck shape as it comes off of the CNC machine. You can sort of see the cutter paths every 50 thousandths of an inch as it nibbles its way through the neck. Behind us over here are all of the fixtures which hold the wood onto the CNC machine. And as I said, one of the first challenges in making any of the parts is figuring out how to hold it. This one here with the aluminum chassis and these cylinders is for one of the first operations of cutting the truss rod slot and the slots for the carbon fiber reinforcing bars. And that holds the neck in position for that operation. Cool. This is the world's most expensive Dremel tool, which I think everybody probably in the UK knows is a brand of hobbyist high-speed drill. This is $5,000 of Japanese-made precision technology by NSK Nakanishi Corporation, and it is a brushless electric high-speed spindle, turns 50,000 RPM, and one of the beauties of it is that it's so quiet when it's turning that you can't even hear it over the background noise of the circulating pump on the big machine. We are using this for the peghead logo inlays and for fret slots. And these are the cutters that we use for cutting the fret slots, which are 0.6 millimeter or 20 thousandths of an inch in diameter. The engineers at CF Martin and Company turned me on to these. They use a similar process, but they had $160,000 to set up for theirs. We did it for $5. And these cutters are made for the printed circuit board industry, and they're just fantastic. They're very reasonably priced, incredibly durable. Other than like doing something really dumb, we haven't even broken anything yet, weirdly, in cutting breadboards, but you know, we'll use them and toss them as they start to get dull. This, as I mentioned, this was $5,000, and one of my machinist colleagues said, well, call the company up, they'll send you a loaner one to try out. So I did, and I called up the company, which is in Orange County, California, where a lot of aerospace stuff is, and the guy there said, oh, well, all the loaners are out, I'll send you a brand new one. I went, okay, knowing full well that once I got it and tried it, it was, here's my Amex card, you're not getting it back. And it's a wonderful tool. And one of the beauties of it is that we're cutting the fret slots with it, which means that we can do any scale length of instrument. It takes about 2.5 minutes to cut all the frets, 24 fret slots. So with writing a simple program, we can do any scale length of fingerboard, which has been just wonderful, because now for the basses we're doing 34 and 35-inch scale lengths and short scale ones that are 30 and an eighth. In guitars we're doing 25 and 25 and a half, etc. So it's a wonderful tool. Set up for gluing fretboards onto the necks. The aluminum beds that are on there have a curvature cut in them that corresponds to the curvature on the fretboard. We now do almost all the, well, virtually all the work on the fretboards before they get glued onto the neck. The radius is cut on the top, the inlays are put in, the inlays are sanded flush, then the fret slots are put in, and then it's glued to the blank, and then we finish out taping the neck. And we're gluing on these fretboards with a tropical hardwood epoxy because we're bonding together the maple, the carbon fiber, and the rosewood. So these type of Destaco clamps are good. Epoxy is like a cement. You don't want to squeeze it as tightly as you would a wood glue, which works by soaking into both surfaces. Epoxy, you need a thin layer, a very thin layer of it to remain there to work properly. The engineer and his son both are bass players and have incredible machining and computer and electronic chops, and I knew they could do it, and they just like took it and ran. And then I said, oh, this is a barter deal, you're both bass players? Excellent, go for it. So this machine cuts the fret wire which comes on these spools, coiled crown out into pieces. I'll show you here. There's a piece of the fret wire with the tangs removed so that it doesn't poke out through the edge of the fingerboard, and also will lay over binding, things like that. Ian's just started this up here. It's got a touch screen which enables you to set the length of the piece of fret wire and the number of pieces you want cut. There it is. So come around here. You can see there's the controller screen. Ian's going to punch in the length or whatever quantity. Okay. There's the length, right? 2.570. And now it'll feed the wire off. Previous to this, we had a metal, what's called a metal chop saw, which is just a little thing on a lever with a wheel, and a similar sort of air-powered die, but somebody had to sit there all day long, pushing it through to the stop point, cutting it off, And when we're now doing 30 bases a month in the USA shop here, each with 24 frets plus a few other things, it was a lot of really dumb time that could be used more productively, especially with the skilled crew we have here. So this has been a wonderful, wonderful new addition to the shop. At least that part of that repetitive operation is now in its hands. For pressing the frets in, attached to a $70 automotive torque wrench available at any auto supply shop, which regulates the pressure. So we have it set at a number over here, which is sort of irrelevant in relation to the hundreds of pounds of pressure this little press develops. But there's the shaped striker here, and this enables us to push the frets in with consistent pressure regularity, which makes it a lot easier to level them later and make sure they're seated properly and all of that. Brand new project, acoustic electric guitar, which we will be debuting at NAMM. The top on this is reclaimed redwood from water tanks that have been on the roofs of New York City office buildings for probably 50 or 60 years. They rebuild them with redwood, and then we get to reuse this material. This is carved both inside and out, chambers here and here. You can see that there. The back of this one is alder wood. Great sounding instruments. These that are getting ready to get carved. Here's a big chunk of buckeye burl that hasn't gotten sawn up yet. This is in its most rough sawn state. We usually try to get this wood in, only purchase it scalded where it's already cured and colored up. And one time my supplier sent me a bunch of it, was eager to get me to pay him, and sent in slabs of it. Went, oh yeah, it's starting to turn colors. And we got it here, and we tried the most ridiculous things of, like, first off, the simplest thing was wrapping it in black plastic in the summertime and leaving it in the parking lot to cook. Then slathering it with, soaking it with beer, which did not help much. Then slathering it with mayonnaise, which was disgusting.
What day was that?
And in the end, it just really didn't work. There has to be a certain sugar level in the wood itself for the whole process to, to get going. And artificial enhancement of it doesn't seem to work. It's a nectar, the body base that's glued up with these claws that grab the body and press it against the neck. This body is spalted maple. The fingerboard is bird's eye maple, and this is abalone inlay, which is beautiful stuff. This is real Kawa abalone shells, and put together with a process that is patented by a man named, his trade name is the Duke of Pearl. And what they're doing is taking real abalone shells and slicing them for the best parts of the color and gluing them together into like a sort of abalone plywood. And if you look at there's some black lines here, which I know are the actual adhesive substrate. But it's fantastic material. It comes in sheets about like this, and the color runs all the way through it. So when you inlay it in the fingerboard, you don't have to worry about the color disappearing as it might do with natural shell. I just saw the Duke of Pearl at a little Louvre show. I'm sorry, I'm not sure I have a picture on my phone, but he has a pearly outfit, like a pearly cockney from London, with a top hat and jacket completely covered with stuff like that. Duke, Chuck Erickson, that's his real name. Table for a rec space. One of our customers. This is going to Johnny Deshay, one of our loyal customers. And this wood only grows really in the Pacific Northwest, in a range from southern Oregon up to British Columbia. And it's really a mystery as to what causes it. You can't plant seeds from one of these trees and get another one like this. So it's either an environmental or some sort of disease that causes this type of pattern in the wood. I've been out there, and I was in a national park having a cup of coffee looking at this beautiful lake, and I looked at the tree next to the parking lot and could see it was quilted maple of 5A grade. And it's a good thing I'm not that kind of guy who didn't have a chainsaw, because it would have gone in the trunk of the car. The vivid patterning happens right under the bark of the tree, so you can go through and see these things. The only thing they do know is that it does seem to occur in trees that grow near creeks and in ravines, so perhaps it's some sort of bacterial reaction to some bacteria the tree is picking up or something. But it's just gorgeous, and a relatively fast-growing tree. These are soft maple from the Pacific Northwest, and of course it's a temperate rainforest there, so these trees will grow to maturity in 40 years or something like that, sometimes less. But it's in demand. When I first started using it, I used to be able to buy long planks of it from my suppliers out there, and now we pretty much bid on chunks of it. If somebody wants this type of 5A grade, it's become like lobster. I have to say market price. Let me shop around and see what's available, and then I'll let you know how much it's going to cost, because it's become that much. On a new project, I'll show you another one up front. This was one of the first ones. Acoustic electric bass. This has a Sitka spruce top that you can see has been carved both on the inside and the outside of it. And these will have a Fishman piezo bridge and an EMG active pickup in it. We should be able to use Aguilar pickups in it soon. Right now there's an impedance issue between the two systems, which we have to have some of these engineers sort out. Here's another test piece with the redwood at the top. And it's a test piece because that's what test pieces are for. Went through the top a little bit over here, but part of the learning process. You can see it's also carved on the inside here too. And even here, it's actually a fourth. We're not sure what that means, but when we did get it together, it sounded great. And believe me, it was a happy accident. Calvin is leveling the frets here with a file that's backed up on a wooden block. And of course the frets have to be level within a thousandth of an inch. He'll go over and inspect them with the magnifying visor and go through a whole process of filing them to taper, bend over the, file over the ends, and to recrown the top so the curvature is correct, and then different grades of abrasive. Yeah, there's the curved file with diamond dust on it.
Just bevel it, to sand it down, and then put a radius on it.
Yeah, that file he's got in his hand now is impregnated with diamond dust and is used to put the curvature back on the top of the fret after it's been leveled and perfectly in line with the others. Okay. That Ian is working on that have reclaimed redwood. This is from those stumps from under the rivers in the Pacific Northwest. The back is black walnut, which grows in the Northeast, local wood here. And one of the prime tools, here's a commercial for Dynabraid, orbital sanders, air-powered, made in Buffalo, New York, and absolutely a fantastic piece of equipment. We beat them to death for about 10 years before we replaced them, and they're just wonderful. And there's just a lot of skill work that goes into the sanding. You know, machines can do a bunch of stuff, but it takes folks with hands and eyes and ability to like finish them out so that they're really right. A lot of hours go into that, as Ian can attest to, and everybody around here. Thank you. Final assembly maestro. And a heck of a guitar player too, and singer. Here's a black, this is Ultra Amber Burst with high gloss finish on it. This is actually an unusual pickup setup in that it has a 35 TW and an MM4 in the bridge. This is going to our dealer in Reykjavik, Iceland. One of my fishing buddies and one of my favorite customers. Here's a partially assembled Coda P with Aguilar P pickups in it, bird's eye fretboard and abalone inlays. And this one, in fact, actually is a test piece that has also reclaimed redwood from California on the back, so it's very lightweight. Did you get a chance to? This thing feels like it weighs 7 pounds or 7 and
I haven't
change.
weighed it, but
It's definitely.
yeah, no, definitely. It's
Yeah.
set up to play passively,
Yeah.
waiting for the pot to go.
Oh, okay. Here's one of the import Coda Pro bases made in Korea with DMG HC pickups in it. This has got an alder back on it, quilted maple veneer top. What else do we have? Yet another test piece. Right. Test piece. This one hopefully will make it to the NAMM show of the new acoustic electric bass. This one's cut for an EMG 35. And among the challenges was getting the wires from one place to another. So here is plastic tubing, which will get it from the battery compartment down into here, and another one which is affixed underneath this hole here, so the piezo wire from the Fishman Bridge will slide through there. So we don't have to do blind maneuvers in the dark for Jimmy to try to get the wires through. So that actually seems to have worked out nicely. This one still needs to be sanded. Oh yes, lovely black stain, quilted maple, abalone. To a fellow named Andrew Bunk, who's one of our loyal customers.
That one's getting chrome hardware.
Uh-huh. Okay. And parts. All the doodads, all the myriad doodads that go into instruments.
270 degrees apart.
Right. Here's, what is this one going to get? Probably black cherry, I can't read it. But
That's black cherry,
yeah, it gets stained with black stain first, soaks into the highlights of the grain, then it gets sanded off, and then Jimmy will stain it with a red stain for the field. And as I said, then our finishing subcontractor once a week comes by and drops off and picks up from us, and they do the high gloss finishing and polishing at another location about 20 miles from here, up in the ski town of Windham. Let me just hang this back up here.